is out here S of 0, okay, which is some data which was at the bottom of the stack, right? So this is a logical violation of the concept of a stack, right? Okay. So now similarly you have queues, okay, where it's simple. I think you all know about queues, that whatever goes, you just the idea, right? Okay, so that's your queues. Just as an exercise, I would like to give you this problem that you have two stacks, okay, and you want to simulate a queue using the two stacks. Okay, so you have, this is your stack 1, okay, this is your stack 2, so this is the top of the stack, okay, you want to simulate a queue using these two stacks. Okay, so that's the problem. Okay, so you can of course just perform the logical operations of a stack, and you want to somehow get a queue out of this. Just think on this problem later, just you can just contact anyone and finally I can give you the solution. It's a problem from the Art of Computer Programming written by Dr. Okay, so it's a very standard book. Okay, so might have heard of it, right? Okay, so come back to this problem later if you want, right? Okay, so now just this is the basics that I was talking about. Okay, so now we can think about now to move to the next thing. So we can just do one thing. We can either cover priority queues first, or binary index trees, or segment trees. Do you have any opinions about which one should be taken first? Any priority? Start with priority queues. Fine. Okay, we start with priority queues. Okay, so now when we define a queue, okay, so what's the concept of a queue? Then whatever it's as you said, it's a FIFO that first in, first out, right? Okay, so now why is it the first out? Look at the part first out. Okay, that's the reason is that we are defining some priority based on the order of insertion. Okay, so if we inserted an element the first, it should be removed first, right? Okay, but this can be generalized into another concept in which we might want to remove another element which has higher priority. We're giving the highest priority to the element which is inserted first, right? This is the normal queue that we talk about. So priority queue is just a generalization of this concept in which we are removing an element, okay, based on some priority. So that might be the element. So if you are inserting numbers and removing numbers from the queue, it might be something like we are inserting 10 and inserting 5. So then 5 will come out first because 5 is smaller. So smaller elements have higher priority, right? Or you might have the biggest element has the highest priority, right? So you can have different concepts, okay? You might define another function which will define the priority of your queue, right? Okay, so now just let's look at how do you implement this. Say I'm just take up a programming contest approach. That if you want to implement this in a programming contest, okay, where you have, assuming you don't have any, priority queue implementations from your, SPL and all, you just want to write something on your own, okay, and you don't have any, implementation which you've written, beforehand. So let's see how we could go about it. Okay, so for that, we need to introduce a concept, okay, another data structure which is known as a heap. Okay, so a heap is nothing but a data structure which helps you implement the main purpose of a heap has always been to implement a priority queue. Okay, so now let's go about a heap. So what exactly is a heap? Okay, so heap is firstly it's a balanced data structure. So what do I mean by a balanced data structure? Okay, so one thing is that, so you might have heard about trees, right? A tree. Okay, so how do you know about binary trees, right? So what's a balanced binary tree in which the heights are somewhat the same? Okay, I'll just go a bit slowly. Okay, fine. So now coming to a heap. So what's a heap? Okay, so we have something like this is your first element. Okay, that's the top of your heap, right? You have two children, of course, or might be one or two. Okay, we have two again for this, right? So on. So what is a balanced heap? Is one in which the missing elements are always towards the end. Okay, so this, if I'm just removing this part, this is not a balanced heap, right? Because this is not balanced. Okay, so in other words, if I'm labeling this from 1, 2, 3, 4, 5, 6, 7, so on. Okay, so we always should have that. Say if it's 1 to n, the number of elements. Okay, so now we should always be able to label it like this: 1, 2, 3, 4, 5, 6, 7, so on, 8, 9, 10, 11, so on, right? Okay, so if this is missing, this is not, it's not proper. Why? Because we have 4, 5, we don't have 6, right? So we should have 7 out here. Okay, getting it? So this is one thing. It always has two children. And there's another concept that says that the element at the root, okay, will always be smaller than the element at the children. At the root, in the sense, at any parent will always be smaller than the children at the element at the children. Okay, so say if we have 1 out here, we can have 2, or say 7 out here. Okay, so now see, this is a 2 out here. Sorry, this is a 7 out here. So we can have a 5 out here because even though 5 is smaller than the 7, we can have it out here because 2 is always smaller than 5. So we can have it out here, but we cannot have it out here. The 5 cannot come out here. Getting it? Okay, so there's no proper ordering, like that the elements in the above level should be smaller than the elements in the before level. That's not the concept. The idea is just about the parent and the children, immediate children relationship. Okay, fine. Okay, so we can just fill up this. We can have a 3 out here. We can have we can't have a 6, we can make it a 16, we can have a 10 out here. Okay, so this is your concept of a heap, simple concept. Okay, so now let's see how this can be used to implement your priority queue. Okay, so in a priority queue, I'm always supposed to remove an element which has got the highest priority, or you can take it the lowest priority as you wish. Okay, just we are looking at it. I'll just talk about it in terms of highest priority, right? Okay, so now we always assume that the element at the top is the one with the highest priority. So right now what I'm demonstrating out here is a heap, okay, in which the priority, I'm just talking and I'm just merging the concept of your heap and your priority queue. They're basically different things, okay, but I'm just merging the concept with an implementation in mind, getting it? So I'm just talking about priority along with the heap, so don't confuse it, okay? The idea is just, I'm talking about a priority queue implementation, and because of that I'm coming to heaps, right? Okay, so now this is the element which has your highest priority. I told you this will be your element. Okay, so if you're considering the lowest element to have the highest priority, the lowest element comes out here, right? We have bigger elements in the children. Okay, so now, say if you want to, a basic operation of your priority queue would be to extract an element which has the highest priority. So that's simply going to be this element, right? Okay, right? So that's simple. But now the concept, now there's some problem with this, that we might want to delete some data, or we might want to insert something, right? And so when we are inserting something, we always will insert in a manner that will ensure that the structure of this heap doesn't get destroyed. Okay? Because that's what gives us the property, that's what gives us, as we perform many insertions and deletions, and the basic structure of the heap is what tells us that, that the element which we want is always at the top. Right? That is because we can say that this is, smaller than this is smaller, these are all smaller.